Here we would like to find the equation of the tangent line to the graph of the function of x, defined to be square root of x minus 4 at the point 5, comma 1. So the first thing to do is to write out the formula for the equation of this tangent line that includes the derivative that we will need to find. So the equation is going to be written as y is equal to the derivative of x naught times x minus x naught plus y naught. Okay, so we need to find the components. First we need to find the derivative and then find the derivative value using the value of the x naught. Now first of all, x naught and y naught are these respective coordinates that we're given, right? So we're going to indicate them as x naught and this is going to be y naught. So now let's find the derivative. So we know that the function of x is given as square root of x minus 4. And just for the sake of pre-calculus, I'm not going to use the power rule. I'm going to use the pre-calculus formal definition of a limit to find this, right? So we know that the derivative is going to be such that the limit as h approaches 0 of the fx of the f of x plus h minus f of x divided by h, right? So this is the formal definition of a limit that we need to use. And of course now we're going to be substituting the values and the information that is available. So we're going to do limit as h approaches 0. And fx plus h basically means that you're going to substitute the x in the input with x plus h. And accordingly, you're going to substitute this x with x plus h. Right? So the function of the x plus h is going to be x plus h minus 4 inside a square root. Right? So this is going to be x plus h minus 4. And then minus f of x. So you're going to copy this down. Minus the square root of x minus 4 divided by h. Okay, and then as you can see, we cannot determine the value of the limit right away directly by plugging in h is equal to 0, right? Because we will have undefined, right? You cannot divide by 0, right? So you can't divide by 0. You have to get rid of the h somehow. Okay, you have to get rid of the h, because not only you cannot divide by 0, well, you can unless the top is 0. The top will be 0 because if h is 0 on the top, then it will be x minus 4 inside the square root minus itself, minus x minus 4 inside the square root, which will give you 0. And 0 over 0 is indeterminate, right? So you can't plug in h is equal to 0 and expect to get a straight out answer. You have to do something else. So to do something, you need to actually use the conjugate of the top, the conjugate of the numerator. All right, so the conjugate of the numerator, multiply both the denominator and the numerator by the conjugate of the numerator, meaning these two terms will be the same except there will be a plus sign. All right, so what I'm saying is we will need to multiply both sides, both the numerator and the denominator, by the conjugate, which is going to be x plus h minus 4 plus, instead of a minus, plus the square root of x minus 4 okay, like that, both the numerator and the denominator. So as a result, what should happen is, notice that this will be like a FOIL method now, because the first product will be this times itself. the next product will be this times this, then the third product will be this times this, and then the last product will be just the minus and plus signs of the same term. So as you can see, the outer and the inner step cancel each other out, because this times this is positive coefficient, but this times this, the inner step, is the negative coefficient of the same terms, pretty much. So they cancel each other out. So the only thing that remains is the first product and the last product. The first product means that you're essentially getting rid of the square root, right? Because you're squaring these two by multiplying themselves, right? So it's going to be just without the square root, x plus h minus 4. And the last product, we already said the outer inner cancel each other out because of the plus and minus signs. The last product is squared, but except there's a minus and plus multiplied. So, and you know minus times a plus gives you a minus, right? So it's going to be minus. And now square root of x minus 4 times itself times another square root of x minus 4 is getting rid of the square root, like in the first case. So, and don't forget the parentheses though, because there's a minus that applies to the entire thing, right? So x minus 4 inside parentheses, right? Like that, right? And divided by h. And now look what happens. As a result, h is the only one standing. Okay? Now, I forgot one thing. I multiplied, I put h here, and it's not just the h, so I have to kind of do some revisions here. I hope you noticed that mistake as well. It's not just the h, it's also this that I forgot to write up, right? So it's going to be h times square root of x plus h minus 4. And then don't forget it's going to be a plus, right? So plus, okay, square root of x minus 4. All right? So now what happens is the top has the h standing. The bottom will have everything copied as before. X plus h minus 4 plus square root of x minus 4. Right? As you can see, the h is the only one standing because we have x minus x, that's 0. And then minus 4 plus 4, right? Two minuses give you a plus 4. Minus 4 plus 4 is zeros, right? So the x and these 4's there are gone. So the only one standing is h. And as you can see, h can be conveniently canceled out with this h, because this h is being multiplied to everything here. So as a result, what you have is just 1 on the top and all the square roots there that you're adding. X plus h minus 4 plus square root of x minus 4. All right, and now guess what? If you evaluate the limit at h is equal to 0, you will be successful. Because as a result, what you get is 0 here for the h. So as a result, you get x minus 4 without the h here because it's 0. You're evaluating it at 0 for the h because that's the target value. The h approaches that value. So you want to evaluate it to see what the function value is, the limit is. So h is 0, so x minus 4 by itself inside the square root plus another square root of x minus 4, right? So that makes it 2x squared. 2 square roots of x minus 4, right? So it's going to be twice the square root of x minus 4. So that is your derivative that you just successfully found. Okay? So as a result, now that you found this derivative, we can find the derivative at the target value of x naught, which is 5. Okay? So now let's find that. So the derivative at x value of 5 is going to be 1 over 2 square root of 5 minus 4. And that's going to be 1 over 2 times square root of 1, which is 1 over 2 times 1, which is 1/2. All right, so the equation that we need now is going to be 1/2, we just found that, x minus x naught, which is 5, plus the y naught, right, which is 1. So if you simplify this, you should get an equation in the mx plus b format as y is equal to 1/2 x. Now, minus 5 over 2 plus 2 over 2, because this can be written as 2 over 2 with the denominator 2. Minus 5 plus 2 is minus 3, right? So minus 3 over 2. So this is your desired equation of the tangent line to the graph of the function of square root of x minus 4 at the point 5, comma 1. Thanks so much for watching. Hope this was helpful. See you in the next video.